Hello, welcome back again to Physics De-Mystified. So, particles and antiparticles then. Now, antimatter, something that crops up in science fiction movies and TV series. It sounds exotic, dangerous, and the solution to all our energy problems. And in many ways, this is a pretty fair summary of what antimatter actually is. However, it's not quite as sci-fi as you may think. For example, did you know that it's regularly used in hospitals to examine inside bodies and to trace and diagnose medical problems, particularly in the brain? Now we're going to be looking at antimatter, or particles and antiparticles if you prefer, as well as arguably the most famous physics equation in history, E equals mc squared. Now, when matter and antimatter particles, i.e. the particles that make up everything in our universe, meet, they destroy or annihilate each other, and energy in the form of radiation is released. We can make use of this effect in a positron emitting tomography PET scanner. A positron is the antiparticle of the electron. A positron emitting isotope is administered to the patient, and some of it reaches, say, the brain via the blood system. Now, each positron emitted travels no further than a few millimeters before meeting an electron, and they are both annihilated. The two gamma photons that are produced are detected, and a computer gradually builds up an image. Positron emission takes place when a proton changes into a neutron in an unstable nucleus, one with too many protons. Now note the positive beta particle, positron, and the neutrino, that little V sign. Now positron emitting isotopes are not naturally occurring, and they're in fact manufactured by placing a stable isotope, a liquid or a solid, in the path of a beam of protons. Now, some of the nuclei will absorb extra protons, and thus they become unstable. They become positron emitters. The existence of antimatter was first proposed by the physicist Paul Dirac before the first antiparticle, the positron, was discovered. Over 20 years previously to this, Albert Einstein had shown the mass of a particle increases the faster it travels, and his famous equation, E equals mc squared, related the energy supplied to its increase in mass. More significantly, Einstein said that the mass of a particle when it's stationary, its rest mass, m0, corresponds to rest energy, m0, c squared, locked up as mass. He showed that rest energy must be included in the conservation of energy. Dirac predicted the existence of antimatter particles, or antiparticles, that would unlock the rest energy whenever a particle and antiparticle meet and annihilate each other. Dirac's theory of antiparticles predicted that for every type of particle there is a corresponding antiparticle that, 1, annihilates the particle and itself if they meet, converting their total mass into photons. 2, has exactly the same rest mass as the particle. 3, has exactly the opposite charge to the particle if the particle has a charge. In addition to this, Dirac predicted the opposite process, pair production. In this process, Dirac predicted that a photon with sufficient energy that passes near a nucleus or an electron can suddenly change into a particle-antiparticle pair, which would then separate from each other. Let us now look at annihilation and pair production in a little more detail, starting with the link between particles, antiparticles, and E equals mc squared. The energy of a particle or antiparticle is often expressed in millions of electron volts, MeV, where 1 mega electron volt equals 1.6 by 10 to the minus 13 joules. 1 electron volt is defined as the energy transferred when an electron is moved through a potential difference of 1 volt. Given the rest mass of a particle or antiparticle, its rest energy in mega electron volts can be calculated using E equals mc squared. Now remember, annihilation occurs when a particle and a corresponding antiparticle meet, and their mass is converted into radiation energy. 2 photons are produced in this process, as a single photon cannot ensure a total momentum of 0 after the collision. Therefore, the minimum energy of each photon, hf min, is given by equating the energy of the 2 photons, 2 hf min, to the rest energy of the particle and of the antiparticle, i.e. 2 hf min equals 2 E0, where E0 is the rest energy of the particle. The minimum energy of photon produced can be calculated using the formula hf min equals E0. In pair production, a photon creates a particle and a corresponding antiparticle and vanishes in the process. For a particle and antiparticle, each of rest energy E0, we can calculate the minimum energy and minimum frequency F min that the photon must have to produce this particle-antiparticle pair. Now remember, c is the speed of light in a vacuum, 3 by 10 to the 8 meters per second. Therefore, the minimum energy of photon needed, hf min, is equal to 2 E0. For example, the electron has a rest energy of 0.511 mega electron volts. Therefore, for pair production of an electron and a positron from a photon, the minimum energy of a photon is 2 times 0.511 mega electron volts, 1.022 mega electron volts, which equals 1.64 by 10 to the minus 13 joules. We can see from this that a photon with less energy could not therefore create a positron and an electron. Well, that's enough for this video. Next time we will look at particle interactions in more detail, dealing with the electromagnetic and weak nuclear forces, and introducing Feynman diagrams. Remember to subscribe to us, click the reminder to get updates when new content is posted. You can support us via Patreon, and make sure you tell your friends all about our channel. And remember, keep wondering about the universe.